Good morning, grade 7s. Welcome to part 4 of lesson 12. In the previous lessons, we went through surface area and volume. Today, we're going through capacity. Now, capacity can be quite difficult and confusing to understand, but once you get your head around the idea, it makes it a lot easier. Okay, so we said surface area was the space on the outside of a 3D object. Volume was how much space was inside the 3D object. Now, capacity is almost the same as volume, except capacity we are talking about milliliters or liters or kiloliters. Okay, so it says capacity is the amount of space inside a solid. It's how much liquid or gas a container can hold. We measure capacity in centimeters cubed or meters cubed. Now guys, the reason I'm saying centimeters cubed or meters cubed is because we're going to use volume to get to capacity. So later on in the lesson, you'll see that we're actually talking about milliliters and liters. Okay, so it says, it's very important to remember that we are going to use volume to calculate the capacity of a solid. So let's take note of a few important things before we go on. This is converting between volume and capacity. Now guys, this will sound very confusing, but this is just something you need to learn out of your head. These are conversions that you need to know. Alright, so 1 centimeter cubed is equal to 1 millimeter. In other words, 1 centimeter cubed, that's the volume of a cube, right? So if we had a little cube of 1 centimeter by 1 centimeter by 1 centimeter, it means that it would be a tiny little cube like this. And inside that little cube, we would be able to fit 1 milliliter of liquid. So that's what it means, all right? The next one, if we had a cube that was 1,000 centimeters by 1,000 centimeters by 1,000 centimeters, so a much bigger cube, all right? We would be able to fit 1 liter inside that cube. So the little one, we would fit 1 milliliter. Inside the big one, we would fit 1 liter. And please remember, in 1 liter, we have 1,000 milliliters, okay? Then, if we had a cube that's length was 1 million centimeters by 1 million by 1 million, in other words, a very big cube, we would fit 1 kiloliter inside this big cube. And that's because 1 kiloliter is equal to 1,000 liters. Okay. So basically, the main thing you need to remember here is this conversion. That's the most important, that in 1 cubic centimeter we can fit 1 milliliter of liquid. Right, then we go on to the bottom. 1 cubic meter, so if we had a cube that was 1 meter by 1 meter by 1 meter, in other words a very big cube, we would fit 1 kiloliter. Okay, now if you take note, there's 1 kiloliter and there's 1 kiloliter, but we've got different values that it's equal to. So if it's both 1 kiloliter, it means that these two must be the same as well. So there's our last conversion. 1 million cubic centimeters is equal to 1 cubic meter. Again, this is the most important thing to remember. Okay. So if I can give you some advice, the 3 that I would learn out of my head, 1 milliliter is a cube that's 1 by 1 by 1 centimeter. 1 liter is a cube that's 1,000 centimeters by 1,000 centimeters by 1,000 centimeters. Okay, and oh, sorry. The volume is 1,000 centimeters cubed. And then this last one, a cube that's 1 meter cubed, all right? In other words, the measurements of this cube are 1 by 1 by 1. We would fit 1 kiloliter. Okay, so to make it easier, you can draw a little cube over there. So there's a little baby cube at the back there. Okay, that's a 1 centimeter cube. Then this one, the volume is 1,000 centimeters, meaning that each length of this cube must be 10 centimeters, because 10 times 10 times 10 gives us 1,000. Then the last one, we've got a much bigger cube. That's 1 meter by 1 meter by 1 meter, and that we can fit a kiloliter inside. Now that sounds a bit confusing, but now that we get to the examples, it will start making sense. So example 1 says convert. Now 20 centimeters cubed. All right, in other words, we're going to have 20 of those little blocks. We know if there's 20 little blocks, it will fit 20 milliliters. Okay, the next one, 15 meters cubed. In other words, we're going to have 15 of these big boxes, and in one box we can fit 1 kiloliter. So in 15 of them we can fit 15 kiloliters. Then the last one, 100 centimeters cubed. Now be very careful with this, right? If we look at the centimeters cubed over here, we've got 1 centimeter cubed is 1 millimeter. So 100 of these centimeter cubed would be 100 milliliters. Okay, and if we converted that to liters, remember there's 1,000 liters in a milliliters in a liter. So we would divide by 1,000. So we'd move the comma 3 spaces to the left, because when we divide with a decimal, we move the comma to the left. So that's equal to 0,1 liters. Right, example 2. A rectangular prism has dimensions of 6 centimeters long, 2 centimeters wide, and 1.5 centimeters high. In other words, the length, the width, and the height. Calculate the volume of the prism. So this is what we did in the previous lesson. Volume equals length times breadth times height. Substitute in the values and you work out your final answer. So the volume of this cube is 18 centimeters cubed. Right, now we go on. Okay, I'm just going to make a note at the top here. We said that the volume of the cube was 18 centimeters cubed. Okay, so that's the volume, because this question carries on now. Question B says, how many milliliters of water could fill the prism? In other words, the capacity. So we've got that the volume is 18 centimeters cubed. So there's centimeters cubed. We said 1 centimeter cubed is 1 milliliter. So 18 centimeters cubed would be 18 milliliters. So that's exactly what I wrote there. So we use the volume to get the capacity. Then question C says calculate the surface area of the prism. Now remember, surface area is the area of the outside of the shape. So there's my formula. I substituted in my values, worked out each bracket individually, and then added them together. Okay, so I'm not going to explain that one because we did do it in a previous lesson. Right, example 3. It says calculate the capacity in liters and kiloliters. In other words, we're going to have 2 different measurements of a cube-shaped tank with length of 13 meters. So in other words, they are telling you, let me get a sticky note here. Okay, they are telling you that you have a cube tank. Okay, so there's my cube tank. And they are telling you that the length of the tank is 13 meters. So every side of this tank is 13 meters. Now they want the capacity in liters and kiloliters. But before we get capacity, we need to work out the volume. So we know the volume of a cube is length times length times length. Substitute in 13 meters, so 13 times 13 times 13 is 2,197 meters cubed. Remember, meters cubed because it's volume. Okay, so we've got our volume. Now that we've got our volume, we can calculate the capacity. So 2,197 meters cubed. So if you have a look here, 1 meter cubed is 1 kiloliter. So 2,197 meters cubed would be 2,197 kiloliters. That's what they asked for. But they also asked for liters. So all we need to do now is convert kiloliters to liters. And in 1 kiloliter, we have 1,000 liters. So all that we need to do now is multiply this by 1,000, and that will give us 2,197,000 liters. So they wanted liters and kiloliters. There's liters, there's kiloliters. Right, now our last example. Now this last example is quite a tricky one, so you need to pay attention. So it says, a rectangular container with dimensions 2 meters by 3 meters by 5 meters is filled with water. So let's first let that sink in. I'm going to draw my container. Always draw a picture. It always helps to draw a picture. So they say it's 2 meters. Is it 2 meters by 3 meters by 5 meters? Okay, so there is my container. And that container is filled with water. Now it says a cube is placed into the container so that it's fully covered with water. In other words, if this was my container, I take a cube and I put it into this container so that it's covered with water. Now, if you tried this at home, if you take a bucket and you fill the bucket with water and you put a ball or something in the bucket, obviously the water is going to come over the sides. So the water displaces. So that's what would happen here. I put the cube in and the water comes out. So now it says this water is displaced from the container, meaning it comes out, leaving 22,000 liters behind. Okay, so a certain amount came out and 22,000 liters was left behind. Calculate the volume of the cube in centimeters cubed and meters cubed. So this sounds a little confusing, but it's actually very, very simple. So if we have the shape of we've got the dimensions of our rectangular prism, our container, and we worked out the volume or the capacity that this container without the cube in the middle can hold. And we subtract how much is left behind. We will obviously get how much was displaced out the container, and that will give us how big our cube is. Okay, so the first thing we've got to do is work out the volume of our container. So our length, breadth, and height was given to us, multiply them together, and we get that our volume of the container, this is without the cube, is 30 meters cubed. So this picture is 30 meters cubed. Now we obviously want to work with capacity, so we're going to convert that to liters. So we know that 1 meter cubed is 1 kiloliter. So we know 30 meters cubed is 30 kiloliters. If we convert that to liters, we times it by 1,000. So that's 30,000 liters. That's how much is in our original container. Right, now we work out the difference because they said it left behind 22,000 liters. So if we subtract the original amount and the amount that was left behind, then we're left with 8,000 liters. So we know that inside this cube, there's 8,000 liters. So that's what they wanted. They wanted us to work out the volume. We've got the capacity, now we just go backwards. Now we say, right, we've got 8,000 liters, okay, which is then equal to 8 kiloliters. Remember, there's 1,000 liters in a kiloliter. So that's 8,000 liters equals 8 kiloliters. And if we look at this formula here, 8 kiloliters means 8 meters cubed. All right, that's what we've got. And if 8 meters cubed, we now need to get to centimeters. So we can see there, over here, 8 meters cubed. So 1 meter cubed is 1 million. So now we just times it by a million. So 8 times a million is 8 million centimeters cubed. Now guys, I know this probably doesn't make much sense to you, but I want you to go through each example again slowly, understand the examples, draw pictures if you have to, and you will understand them. Now the last little section, there's not much explaining. It's solving problems with surface area and volume, and you can read through those examples on your own. So please make sure you understand this work. Go through it again, practice the examples that I've posted on Seesaw, or these examples, then practice in your exercises. This is all the work we'll be doing this week, and I will hopefully see you next week in my class.